Okay, for today, first off, there's more formula. It's called a formula sheet at the very top of your folder there in Honors Pre-Calc. You've got this formula sheet. It's actually a whole bunch of identities. And you already know some of them. I'd say like it's in the neighborhood of half of them. We've been using them a lot. But you're going to need to know a few more. So that formula sheet, I made physical copies for you. And hold on just a second here. Pausing. So these are the formulas and the sheet you're going to get for the test. So you're going to be able to use all of these formulas during the test. And basically the top three sets, the Pythagoreans, the reciprocals, and the ratios, those you already know. We've already talked about those. So I need to talk about the rest of them. I'm not going to get through them all today because there's a lot. But we're going to try to get through these odd, even, the cofunctions, and the sum and difference. Basically the left side of the sheet. And we'll talk about double angles tomorrow. So, all right, so today I'm going to get through some more of these identities and how you can use them. Then I also want to talk strategies for proofs. So that's the main topic for today. So for right now, would you find the notes that are posted for today, because that's where the homework is going to be, and would you pull up this sheet and then take a screenshot of it so that you can find it like at the drop of a hat, very quickly, easily. Take a screenshot of this sheet, and that way you'll always know where that sheet is. On the actual test, of course, you'll be looking at one on paper. So I'm going to go get the paper copies for you. Pausing. Here we go. All right, so we've already covered the top three sets of them, and we're now going to look at these odd-even identities. Imagine for a moment that you saw a sign of negative x in the middle of a proof. That's strange. You've never even seen that before. You would go, I wonder if that's on the sheet. You'd look on the sheet and it says, oh, that's equal to the negative sign of x. All right, I want to try to help you understand why some of these are the way they are. Let's use the example here. Do you see how all of these are negative, negative, that one's negative, that one's negative, and that one's negative? The only one that isn't negative is the one with cosine. Let me give you an example, and I think this will help you understand it. If I were you, I would take notes on a blank notability doc. You don't want to just listen to me. I know you want to just listen to me, but you only remember 10% of it. So take some notes. I'll show you an example of why cosine of negative x is equal to cosine of x. All right. Obviously, the x, this x right there, is in the angle spot. So let's just look at a typical triangle that's right there in quadrant 1. And let's say that the x, the angle, is 30 degrees. Let's label all the sides in the angle. Sine is opposite over hypotenuse, so sine is opposite. Hypotenuse, and then it went 2 square root of 3. There we go. Any of them negative? No, not in that quadrant. So are you with me so far? Okay. Now, what is the sign of x? Well, we're calling this x for just a second. What is the sign of x? That'd be 1/2. Is it the same as, pausing. Okay, sorry, we got interrupted with an announcement there. But if I did sine of 30, which we're calling x right now, then it would be equal to 1/2. It's equal to negative of the sine of x. Wait a minute. Sine of negative x. Wait a minute, that's sine of a negative angle. Where would sine be negative? Where would negative x be? If x is 30, where would negative x be? Quadrant 4. Very good. It'd be down here. Do you get that if I redraw my numbers, it's going to be -1 and 2, and the square root of 3 side is shared. It's still positive square root of 3. You with me so far? So what's sine of negative 30? This is a negative 30 down here. What's sine of negative 30? Negative 1/2. So sine of negative 30 is the opposite of regular sine of 30. Regular sine of 30 would have been 1/2, but it's the opposite of that. All right, we're going to use those same exact triangles and look at cosine because that's the more interesting case. It's the only one where it's not negative. Why? Because if you take the regular angle or the opposite angle, cosine is the same. Look at these two triangles. What one side doesn't cosine use? And therefore cosine doesn't use the negative. See? Do you get what I'm saying? So therefore cosine of the negative angle, cosine of the regular angle are the same. They're both what? Cosine is adjacent over hypotenuse, so it's √3/2. So in either one of these cases, it's the same. So if you wanted to, this wouldn't even be that hard to memorize. Most of the time, when you do the opposite of the angle, you get the opposite of the function. When you do the opposite of the angle, you get the opposite of the function. What's the one time you don't? Cosine. Okay. So how would you use this again? Let's say there was a negative tangent in the middle of a problem. You could pull it out and put in tangent of negative x. It's not as common. This whole day, everything we're learning today, these things are not as common. All right. Now, they wrote them out. I a lot of times don't write these out because I assume you know that the sister functions are going to act the same. So do you get that the only one that's different is the sister function of cosine? And so, again, same deal. There's negatives all in every single spot except right there. All right. But you don't have to memorize these. I just wanted to show you why it worked. Okay. Next, this one looks really confusing, but if I show you a few examples, I think you'll understand what's going on. First of all, let's change to degrees for a second because we're actually still better at degrees than we are at radians. What is pi/2 in degrees? So really, do you get this is taking 90 minus, and remember x is in the angle spot here. You know, if I say cosine of x, that's cosine of an angle, right? So here's what the cofunctions are trying to say. On a separate sheet of paper. Hold on. You know what the sine of 60 is? Well, first of all, you find its cofunction. What's the cofunction for sine? Cosine. That would be the same as cosine of 90 minus 60, which would be... Did you know that sine of 60 is the same exact thing as cosine of 30? If I draw you a picture, it'll make sense. Here's your 30, 60, 90. 1, 2, square root of 3. What's the sine of 60? √3/2. What's the cosine of 30? √3/2. Does that make sense to you? That's called the cofunction one. So I'll give you the beginning, you give me the end. So what if I give you cosine of 50? What's that got to be? Sine of 40. And I'm just going to use the pattern that they use on the sheet. 90 minus 50, which of course is 40. Okay, so what if you're in the middle of a proof and you're supposed to prove something and it's got this in it? Sine of pi/2 minus theta, or x. That's like saying 90 minus theta. What would that be equal to? It's a cofunction run, so it's cosine. And the whole point is to make these simple, so it's cosine of theta. And that's right off the sheet. What if you saw cosine? I think you get that. Let's change the functions. Tangent of pi/2 minus theta, also known as 90 minus theta. Cotangent of theta. Because this and this add up to 90. Think about it. Take this, take that. The positive theta and the negative theta would cancel and it adds up to 90, or pi/2. All right, so that's the cofunctions. There we go. And now let's get into the ones that are really particularly important for today, which is the sum and difference ones. These guys. Now, if you have the sign of, remember this is the angle, and the angle's been broken into two parts. The parts are x and y. Couldn't that be like 20 plus 30 makes 50? Sure. You could break up your angle any way you want to. So if I had a 60-degree angle, I could call it 30 plus 30. Why would you ever do that? I'll show you later. Or if you wanted to, you could say sine of 10 plus, no, wait, let me think. Let's say that you have sine of 15 degrees. But sine of 15, you actually wanted to break it into sine of 45 minus sine of 30. Do you get how that's the same as sine of 15? 45 minus 30 is 15. But you know what sine of 45 is. You know what I mean? It's a way of figuring out what sine of 15 is without a calculator. Sine of 15 would be the same as sine of 45 minus 30, and we've got a formula for that. It's this. I want you to do that one right now. Everybody figure out what the answer to sine of 15 is. And I know it must seem like, oh, I just grab my calculator and just figure out what sine of 15 is. It's not going to be an option on the test. Okay, so what you should be writing is this. Sine of 15 is the same as sine of 45 minus 30, and then you just follow this little pattern that I circled right here. So that's equal to, now some kids do memorize this. Sine, cosine, cosine, sine. It's not that hard to memorize, but again, I'm not a big supporter of memorizing these because it's just not worth it. You can look them up. In a situation where you'd have to use something that complicated, you'd probably get a formula sheet. All right, so this one we're doing right here, it's sine of 45. The first one is the x. So sine of 45 times cosine of 30 minus, I'll write it down here, cosine of 45 times sine of 30. Is that the way you'd leave it on your test? No, because you know what the sine of 45 is, because it's one of the triangles you've memorized. So this is the part where you'd have to pull out, and I want you to do this. Try to figure out if it's a 1, 1 square root of 2, which is the 45, 45, 90. You should know what the sine of 45 is and the cosine of 45. And then you should know what the sine of 30 and the cosine of 30 are. Because I can make the 30, 60, 90 triangle. 1, 2 square root of 3. You have 4 parts to your answer, and the cool thing is they form a common denominator automatically every time if you do it right. And then when it's a common denominator, it can be subtracted. So as you get started here, what's the sine of 45? You should have said opposite over hypotenuse, so 1 over the square root of 2. Times, and then I told you that when we're done, the first part will have a common denominator to the second part, and you'll be able to subtract them. Pause for a second while you try to finish that one off. Okay, let's see if you're able to pull this off. Cosine of 30. Cosine is adjacent over hypotenuse. So here's my 30. Root 3 over 2. And that doesn't need a common denominator. It's getting multiplied. The point is that the other two that we do, I'll do these in red, they'll also have the same denominator of 2 root 2. So, all right, so let me finish off here. Cosine of 45 is adjacent over hypotenuse. And so 1 over square root of 2. And sine of 30 is 1/2. I know that one off the top of my head. Probably the 8th time it's come up. Okay, now this times this minus that times that. So that's 1 over the square root of, root 3 over the square, 2 root 2, minus that one, which is 1 over 2 root 2. Final answer is the square root of 3 minus 1 over 2 root 2. That's complicated, but that's a typical test question. Now let's do another one a lot like that. Any questions on that one first? Final answer was root 3 minus 1 over 2 root 2. Yes? Good question. You're not ready yet. You could, first of all, I'll keep it simple for now. The ones you would have on the test are more complicated and you're not ready yet. By the end of the hour, hopefully you will be. You could replace this with that in a proof. Okay. And then usually you'll know the angles, like it won't be weird angles. So you'd be able to simplify it down. And like if we had had sine of 15 in a proof, for example, that's what we just did, is we figured out what the sine of 15 degrees is, and we could have replaced it with this in the proof. All right. These aren't as much for proofs as they are for figuring out answers, like what's the sine of 15. Okay, so then I'd like to do the same exact thing, except figure out what the cosine of 15 is. Notice it's in a different spot. Do you want to have two things that add up to 15? Only if you use 10 and 5, the problem you're going to run into is like, okay, now I got to figure out what the cosine of 10 is and like the sine of 5, and I don't know those. So don't choose that option. Choose this option. You want to use cosine of 15. And that's cosine sine. Sometimes people call it cococc. But that's just a trick to try to help you remember that. Then I'm going to let you use the sheet, so don't worry too much about memorizing cococc. All right, so I'm going to get a nice blank screen. I'm going to have you find cosine of 15. And right away, I would split that into cosine of two things subtracted. What minus what makes 15 really well? 45 and 30. Why'd we choose those? Because we know cosines and sines of 45s and 30s. So you're always going to choose angles you know. Then you got to look it up on that sheet. I'll write it out for you. The cosine of x minus y. I could have said theta and alpha. I could have used any letters I wanted there, but this is what you'd have on the sheet. Co, C, and then just try to remember what symbol is in between, because these are always multiplied. It's what symbol is in between. If you wanted to try to memorize it, again, don't think it's that important to memorize it. But if it's subtracting, then it's adding. If you're doing the adding one here, then it's subtracting. So it's always the opposite sign as what you would naturally think. It's a minus, seems like it should be a minus, it's a plus. So try to follow that pattern and simplify your answer down, and your answer might be like 2 minus the square root of 4. No, that wouldn't be right. 2 minus the square root of 3 all over 3 root 3. It's kind of cool. You can figure out cosine of an angle that isn't a 30, a 60, or a 45. Pause for a second while you finish this one off. Okay, let's see if you did it right. So we should have had 45 and 30 because that makes a total of 15. And then this is 45 and this is 30 and this is 45 and this is 30. And then I'm going to super quick make my little triangles. 1, 1, root 2. 1, 1, root 2 and 30, 60, 90, 1, 2, root 3. And now I can answer all those questions. Cosine of 45 is 1 over root 2. Cosine of 30, cosine is root 3 over 2. Plus, sine of 45 is opposite over hypotenuse, 1 over root 2. Times sine of 30, 1/2. And this time it's just the square root of 3 over 2 root 2 plus 1 over 2 root 2. And since they have a common denominator, and they always will, square root of 3 plus 1 over 2 root 2. And that's very similar to our answer from last time. Raise your hand if you had that one right. Awesome. Now, here's how they get more complicated, of course. Let's use this same exact formula, the cosine one. The cosine one for subtraction. Do you get it? Would be very, I mean, if I wanted this to be add, I'd just put a plus here and a minus there. They're very, very, very similar to each other. But I'm going to stick with the same one we just used, which is that one. Now, let's say a problem asked you to figure out what's the cosine of alpha minus beta. You might be like, well, couldn't you just change x to alpha and y to beta? Yup, you could. But then they'll tell you what alpha is and what beta is, and they're not just going to say like, oh, alpha's 15 degrees. They'll tell you what alpha and beta are by drawing you or telling you how to draw a picture for them. So imagine for a moment they say, here's alpha, and alpha is the angle that would have this side being 3, this side being 4, and this side being 5. You'd be like, I don't recognize that one. Well, you just know it's a 3, 4, 5 triangle, right? Okay, so what is that angle? I don't even know. It's like, I think it's like 22 degrees, but that doesn't matter. Because are you ever going to be asked for that angle? No, you're going to ask for cosine of that angle. And sine of that angle. All right, so let me just finish and then I'll show you how it works. And I think you'll see this isn't nearly as scary as it looks. All right, now I'm going to tell you what beta is, this guy. Here's how I'll tell you what beta is. Beta is down here in the third quadrant. That's angle beta. And let's say this is a completely different right triangle. It's the 1, 6 square root of, what would that be? Think about it. Couldn't you find the third side of a right triangle? 36 and 1, so square root of 37. Good. And are any of these negative? Yes, they are. Most common mistake in circle trick. That's negative and that's negative. And I actually forgot this one before. That one's negative. Now, if your job is to figure out what is cosine of alpha minus beta, then you'd look on your sheet, and your sheet would say this, and you'd go, Oh, so I just need to find cosine of alpha, cosine of beta, plus sine of alpha and sine of beta. How am I supposed to know what cosine alpha is? Look right here. Cosine alpha is adjacent over hypotenuse. It's negative 4/5. Find the other three. Put it all together. You'll have your answer. Okay, I'm going to pause for a second and give this a try. Okay, let's see if you did it right. Cosine of beta. Here's where beta is. Cosine in that triangle. Cosine is adjacent over hypotenuse, negative 6 over square root of 37. Plus sine of alpha, which is this one. Sine is opposite over hypotenuse, and so therefore it's 3 over 5. Times sine of beta. Beta's over here again. Sine of beta, opposite over hypotenuse, negative 1 over the square root of 37. And look at that, it's got the common denominator again. So that makes it easy to put together. That's positive 24. That's negative 3. When you add positive 24 and negative 3, you get 21 over 5 root 37. A strange looking one, but 21. There we go. Raise your hand if you had 21 over 5 root 37. Okay, cool. So I want to do a quick review now of some of the major proof solving strategies. Then we'll come back to this and do one of your homework. Okay? Along the lines of solving, you have to be able to do common denominators. Do you get if there had been a tangent here, I could put sine over cosine? Would you give that a common denominator and then handle the fact that it's a fraction inside a fraction and do the whole flip and multiply thing? Everybody combine these two, getting a common denominator, and then do whatever 1 over means to your answer. I'm going to run you through each of the major skills. One is finding conjugates, one's common denominators. Did you realize this was cosine over cosine? And then you can add them together, so you got sine theta plus cosine theta all over cosine. But it's 1 over that. What does 1 over it mean? Flip it. Final answer, cosine is on top now, over sine theta plus cosine theta. That's just an example of how you'd have to know how to get common denominators. Here's one that's an example of how you can factor things. Now, I'm not going to put a 1 on top, actually. I'm going to put a sine theta plus 1. This thing on the bottom here, if you can factor it, you should at least think about factoring it. So it's not automatic that you should always factor that whenever you see it. But in this case, do you get it would factor into something so that the top would cancel with the bottom? Sine theta plus 1, sine theta minus 1, and then the sine theta plus 1 on the top cancels. Do. Final answer is 1 over sine theta minus 1. Could you go get a common denominator for this one and flip it over? You could. I'm not going to make you do that again, but this would be, wait a minute, it's already got a common denominator of 1. That's probably good enough. The technique there was, if you can factor it, you should think about it at least. All right, and the last thing is, I hope when I show you 1 minus sine squared, you're like, oh, that's just backwards of the last time. True, but that brings up a different possibility for a substitution. Cosine squared, very good. And for those of you that are like, where did they get that? It's a fact off the sheet. Sine squared plus cosine squared is equal to 1. And so if you just rearrange that and subtract sine squared from both sides, the minus, see, cancels it out, then it's cosine. So you could replace that with cosine. Okay, so I get this question all the time. What if it's backwards from what you wanted? Like, if it says 1 minus sine squared, you can put cosine. But what if it said sine squared minus 1? That's backwards from what you wanted. You can put in the opposite of cosine. What? Here's the way to think of it. If it's backwards from the way you wanted it, you could factor out a negative 1, and that makes it switch around. And then that's cosine, right? So it's negative cosine. So if you ever you're like in a proof and you're like, dang, if this thing was backwards, it'd be perfect. You can factor out a negative 1, and then it will reverse. I'll give you another one like that. Prove that that's true.
What is that?
That says cosine. Oh, I should have a theta in there. Sorry.
No.
I'll write it cleaner. Okay. Hold on. And that is a CS. That's supposed to be a CSC cosecant. Okay. So the technique I just told you was about how you can reverse things by factoring out a negative 1. So then you take this and you reverse it, and you've got negative of 1 minus cosine squared, and that's good because 1 minus cosine squared is sine squared. Notice I'm not messing with the right side. 1 over negative sine squared then. What's 1 over sine? Cosecant. Negative of cosecant. And that's what I wanted. Okay. So your homework for tonight. Everybody find the file. It's got today's date on it, which is the 10th, March 10th. And I'm going to see if I can pull it up here. So it's found right here. And then in the notes, of course, is where you could find your homework. And your homework isn't going to really start until you hit this page right here. And just for today, because I think it'll be a little, like, I don't think you'll be ready to do 1 and 2. We're going to skip those. We're going to do this one, problem 22, problem 23, and problem 24. 3 in a row right there. Now here's problem 22. I know we're near the end, but let's get started on it together. It's telling you the triangle to use to describe alpha, and it's in quadrant 4. Draw your triangle in quadrant 4. And if this is alpha, cosine is adjacent over hypotenuse. Am I putting that in the wrong spot? You're right, that's quadrant 3. Thank you. Sorry. Quadrant 4. Over this way. Okay, and this is alpha. And then cosine is adjacent, which is right next to it. Here's square root of 5. Over hypotenuse, which is 5. And then what's this last side got to be? Square root of 5 squared, which is 25, minus root 5 squared, which is 5. So it's square root of 20. And that side's negative because it's going down. There. Now that I've drawn that, do you get, for finding cosine, we're going to have to find cosine of alpha, cosine of beta, sine of alpha, sine of beta. Comes right off the sheet. And now I can find anything of alpha. I can find sine, cosine, or tangent of alpha really easy. Okay, then let's go to this one. The second part is completely separate. This is telling you what beta is. And it says it differently. Instead of saying it's in quadrant whatever, it says it's between pi over 2 and pi, which means it's in this quadrant. Don't leave yet. Stay still. Just wait. So you're going to draw this, and sine is opposite over hypotenuse. So here's opposite, and here's hypotenuse. And then you can find the third side. Don't forget that that's negative, and this side will be negative 2. Then that's beta. All right, your assignment is to do those 3 questions. I know it's a more tricky day than normal. Strongly recommend practicing that at home and looking at the answer key. And you'll be okay if you do those 2 things.